Hi everybody, welcome to the Manifold channel. Today we're going to do a project from start to finish that uses Manifold System Release 9. You can also do this in the free viewer. And the project is something that was discussed in the Reddit GIS forum, where somebody wanted to find the percentage of open space in each of the various zip codes that makes up Connecticut. Let's start by creating a map, and I'm going to create new map right there. And now let's create a background layer for it. I'm going to create a new data source from one of my favorites, a Bing Map Street Map layer. I'm going to double click open the map, and then I'll drag and drop that Bing layer into the map to form a background layer. And I can zoom into about where Connecticut is. I'm right clicking and dragging to zoom in. And there's Connecticut. Now let's import a couple of shapefiles from the actual data we're going to use. I'll click File, Import. And I can import multiple shapefiles at the same time. I'm just control clicking them to choose. Click Import, and both shapefiles are imported pretty much instantly. Let's drag and drop that one there. And I'll control click on the tab to zoom to fit that layer. And now let's drag and drop the open space layer here. This ZCTA layer are the so-called zip code tabulation areas, which are proxies for zip codes, or geographic areas that more or less correspond to what zip codes would appear to be. And this layer here is the open space layer, and I'm going to format that slightly differently so we can see it better. And that shows where all the different open space regions are in Connecticut. For example, that's one right there. That's a big one right here that overlaps several different zip code areas. And now let's do a little bit of housekeeping. The first thing I'm going to do is I want to reproject both of these layers into some projection other than latitude and longitude, because we're going to be doing calculations on areas, and we don't want to be doing calculations on areas using degrees. Reprojecting a layer in Manifold is trivially easy. I choose Reproject Component. I click here to choose the new coordinate system that I want. It's not one of the favorites that I want, so I'll choose More. And here under Standard, I'm going to use the filter to reduce that huge list of thousands of possible coordinate systems to this one. I'm going to use the state plane NAD 83, which is pretty much what's used in Connecticut for official state documentation. Click Update Component, and that's reprojected. Let's do the same thing for the open space layer. Again, Reproject Component, click for New, click More. And here also I'll use a CT in the filter box to reduce that down to just the ones I want to see. And click Update Component, and that's reprojected as well. Notice that here the component pane shows that even though the map is in pseudo Mercator, that's what Bing uses, the actual component, this particular layer, is there. And if we open this one on its own, let's open that up on its own, you can see it has a different look than the way it does in pseudo Mercator, because it's being reprojected on the fly in a pseudo Mercator into this in the map presentation. Manifold is so fast that it can reproject these things on the fly without you even noticing it. The other thing I want to do in terms of housekeeping is here in the zip code tabulation areas and drawing. It has a lot of attribute fields, and the one we're going to use mostly is right here. This is the one that's the zip code tabulation areas. That has kind of an unpleasantly long name, so let's rename that field. I'm going to double click here in the schema dialog, and let's just leave that field. Let's call that field ZCTA. Click OK, click Save Changes, and we've just renamed that field. Manifold has extremely powerful facilities for manipulating table schemas and other attributes in table stuff, because Manifold is, after all, a database. All right, so now what we've done so far is we've done our homework. We've reprojected these things into sensible projections, and what we want to do is we want to chop up these open space areas so that each one becomes a separate thing that's aligned to the ZCTA areas, so that only the pro rata share of this big open space area, which is in here, becomes a separate object, and likewise. And the way we do that is it's called a topology overlay. That's actually Esri nomenclature. And what I've done is I've previously filtered this from all the zillions and zillions of different functions we have available here in the transform panel. So let's just use a topology overlay intersect with the focus on the ZCTA layer. We're going to overlay the open space layer, and in the options I'm going to choose the name for the output, Open ZCTA Table. I'll give it a short name, and for the drawing I'll just leave it Open ZCTA. That looks good. So everything's cool. Let's click Add Component. And let's see how this works. It's processing the record. It's going to take it a while to think while it's doing. Okay, it's done with the overlay already. And that created a new drawing called OpenZCTA and I'll drag and drop that into the map. And to see that these things are now chopped up, let's format these polygons using style, and I can thematically format using pretty much any field which varies by ZCTA. Let's use this one, and I'm going to change the color on that to, I'll use this Color Brewer paired palette, click Update Style, and now we can see how what used to be, let me move this layer above that, what used to be one big layer, I'll turn that layer on, I'll double click the layer off, has now been, that one big object has now been chopped into 1, 2, 3, 4 objects, and each one of them has inherited the ZCTA of the ZCTA in which it is located. So you can see all the ones up here are purple, the ones in this ZCTA are blue, the ones here are green, the ones here are salmon colored, and so on. So we've done what we set out to do in terms of chopping those up. Now what we want to do is we want to put this into a form where we can combine the sum total of all the ZCTAs in areas in this particular ZCTA for open spaces in a form where we can then take a percentage out of with the main ZCTA. And the way we're going to do that is that we're going to do a query. Now this isn't quite start to finish because I did have two queries that I started that I had in the project when I started, and the first one is a so-called open sums query. What I want to do is I want to group all the ZCTAs and sum up the area of all the open spaces within each ZCTA into a record. And I'm going to edit this on the fly. I'm going to Control X to delete that. So I want to select the ZCTA and the sum. This expression just gives me the sum total of all the geometries in that area as total sum from open ZCTA table grouped by ZCTA. And what that does is that creates a table like this, where for each ZCTA it gives me the area, the total open space area of all the open space objects that are in there. So if I looked at here, this particular ZCTA here, it would take the areas of all these salmon objects and sum them together to get a single entry. So in order to, and I just ran that, by the way, click it and run it. And what I want to do is I want to create a table from that. So I want to say into open sums. So we'll create a new table called open sums. I'll run the query, and there it created this table called open sums. When I pop that table open, you can see what it did. It just redid what the query does. All right, now what we're going to do is we're going to use that query, and what we're going to do is we're going to build another table. And what I'm going to do is I'm going to take fields from the original zip code tabulations table here, and I'm going to join them with fields from this table here, and I'm going to use the ZCTA as the common field for the join. So to do that, I'm going to use this query right here, and let's also do the same thing of running this first as is, and let's reformat this slightly here. 1, 2, 3. What we're doing is we're going to select the ID field from the ZCTA table, and we're going to select the geometry because we want the geometry so later we can create a nice drawing and color it. And then what we want to do is we want to get the percentage of open space that's in that ZCTA. And the way we do that is we take the total open from the open sums table we just created. Here it is right there. And we're going to divide that by the total area of the ZCTA, which is this expression right here. And then to get a percentage, we multiply that as 100. And to give it a useful name, we're going to name that as percentage open. The as statement here is just an alias. So if we run this, and it's going to be, and we're going to join two tables from this table, join to that table, where the ZCTA field is the same on both. I can run that on the fly, and here's the results table. This is what we're going to do, and we want to put that into a table. And the way we're going to create a new table out of that, instead of just on the fly results table like that shown, is we're going to use this int expression. So we're going to create a new table called %OpenZCTA that has all this stuff here in it. I click that, and it runs, and it runs essentially instantly. Well, it would, because there's hardly any data here. It's a very small database, and there we get the results table that we want. So now let's create a drawing from this. We can create a drawing from this because we have a geometry. And to do that, we're going to right-click on that, and we're going to choose Create New Drawing. And that dialog knows what table we want to use. We have to tell it the coordinate system we wanted to use. And there again, we will once more choose the Connecticut coordinate system. And create drawing. And the result is we've created a new layer. Go back to zoom to the whole thing. I'm going to turn this off. I'm going to turn that off. And now it's going to take this and let's drag and drop it into the map. And what do we have here? What we have here is a new layer, a new drawing, which has been created from the geometry from the former ZCTA, but it has one field to it, which is the percent open, and that's the percent open space. And so what we can do is we can thematically format this by the percent of open space. To do that, we will use the percent open space field, and we'll give it 10 breaks, equal intervals. And what we'll use is I will use a color brewer palette, which is way down here on the list of them. It's yellows to greens. So the more green, the higher the percentage of open spaces in that each ZCTA. And there we've done it. We've just created a map that shows each zip code tabulation area in Connecticut that's colored by the percent of open space that's in that ZCTA. And if you like, we can double click open the original ZCTA open space so you can see how those two correlate. For example, this one here, which is dark green, we can see that does indeed have a pretty large percentage of open space in that ZCTA. And if we want, we can click those up so you can see how this overlay. And let's take a look at another one. Let's take a look at let's say this one down here. Zoom in there, right-clicking and dragging to zoom. As you can see, this ZCTA down here also has a very large percentage of open space, and that's why it's colored dark green. It's showing what the percent is. If we want to see exactly what the percent is, what I can do is I'll click into that, and that'll show us the percentage of open space in this particular ZCTA is about 30%. So that's a lot of open space in that ZCTA. Anyway, we've taken 11 minutes. We've done this entire project start to finish. We've used some elementary SQL. I've actually done this in 3 steps. First, we did the topology overlay operation, topology overlay intersect operation. Then I used this open sums query. There's an open sums query right there. And then I did a join and simultaneously computed the percent. Somebody who's pretty good at SQL, once you get more experience, you can combine all those 3 steps into a single step. And instead of just having, say, this query like this, you could have this one and that one and the topology intersect query all together. And so all that would happen all in one spot, all in one step automatically. And that's pretty cool that you can do that in Manifold, and you can also modify those queries. So learn SQL. It's a very powerful tool. You can take the step-by-step approach when you're a beginner, and you can do the step-by-step approach combining things like the point-and-click transform overlay, topology overlay. And the topology overlay, by the way, will allow you to do things like when you see this button here, add a query, if you like, the topology overlay template will actually show you the SQL that it's using to create that. So if you want to learn how to do SQL, you can use topology, you can use the transform dialog and all these very useful transforms that are in that transform dialog to learn how to do SQL. But like I say, when you're first learning, you can do this in 3 baby steps, where each one is simple to understand and hard to get wrong. And the other nice thing about chopping it up into 3 different queries like this is that if you want to implement this in some other system, like say ArcGIS or QGIS or something like that, you can see what these different queries are and how they work, and you can do the equivalent in whatever SQL that your GS provides. I don't think you're going to find a faster and easier SQL to use than the one that Manifold uses, because it's an extremely comprehensive, very powerful, very fast SQL. It's fully powerful. It's fully parallel at all times. But other systems do have SQLs as well, and SQL is the tool of choice if you want to do things like these sorts of operations. I repeat, you can do all this in the free viewer. Nothing that we've done here requires Manifold System Release 9. Every bit of it can be done in Viewer as well. So download Viewer and give it a try and start learning how to use SQL and how to do spatial operations with SQL, and you can do all that for free, no strings attached. Anyway, I hope you've enjoyed this video. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.